Okay, today we're covering 4.4, which is graphs of sine and cosine. Your objectives are to analyze the sine and cosine functions. You're going to transform graphs of basic sinusoids. You're going to find the frequency of a sinusoid, and you're going to model periodic behavior with sinusoids. What is a sinusoid, you may ask? Well, it's basically just a sine function. Your language objective is to describe the differences between the sine and the cosine functions. Periodic function is a function that repeats its values after adding some definite period to the variable. Okay, so let's go to this website and see exactly what a periodic function looks like. Okay, so you can see over here we're at 0 radians or 0 degrees. As I increase the angle, watch to see what happens to the sine graph. It starts at 0, goes up to a maximum of 1 at pi over 2 or 90 degrees, goes back down to 0 at 180 degrees or pi, hits negative 1 at 270 degrees or 3 pi over 2, and at 2 pi it goes back to 0, and now the cycle just repeats. That's what a periodic function is. It's a function that repeats. Let's take a look at cosine as well. So the graph of cosine is actually the graph of sine shifted 90 degrees left. Let's get rid of sine here. So at 0 degrees, the cosine function is 1. It drops down to 0 at 90 degrees, to negative 1 at 180, back to 0 at 270, goes back up to 1 at 2 pi or 0 degrees, and then it repeats. So periodic function just repeats exactly. Same periods, same shapes. Okay, so what do we know about the sine function? Well, we know the sine function is periodic. So what do we know about the sine function? Well, we know that it's periodic. And because it repeats after one circle, we know that the period is 2 pi, or 360 degrees. Its domain. Well, there's an x value for every real number, so we'll have to say the domain is all real numbers. And the range, as you saw on the little applet we just did, goes from negative 1 up to and including 1. So, it repeats between those values. Y-intercept. Where do y-intercepts occur on the sine function? Well, if you look at the graph, you can see the y-intercept is at the point 0, 0. Okay, what about x-intercepts? Well, if you look at the graph, you can see that it hits the x-axis at 2 pi, at negative pi, at 0 pi, at 1 pi, and at 2 pi. 0, negative 1, I'm sorry. So if we let n equal an integer, if you remember what an integer is, it's the set negative 2, negative 1, 0, 1, 2, and so on, no fractional numbers. Then x-intercepts occur at the points n pi. So we just take the integer and multiply by pi. So we get negative 2 pi, negative pi, 0 pi, 1 pi, 2 pi, and so on. Okay? Now we know that maximum values occur at 1, but where do they occur? So we're going to do the same process that we just did for the integers. We have a max value here at negative 3 pi over 2. It's 0. Oh, that's wrong. That's completely wrong. At pi over 2, we have a 1 at pi over 2. And if we were to extend this graph you could see we have 3 pi over 2, this is 4 pi over 2, right here at 5 pi over 2. And sloppily put in a 5 pi over 2. There would be another max. So you can see what we have here, a list of odd numbers. No, not quite. What we have here is 2n pi plus pi over 2. So for example, if n was 0, 2 times 0 plus pi over 2. Okay? If n was 1, we'd have 2 times 1, so 2 pi plus pi over 2, which is 5 pi over 2. And those would be maximum values, not minimum values, so they belong up here. Okay, let's look and see where the minimum values occur. Well, we have a minimum value at negative pi over 2, at 3 pi over 2. And you can see the difference between these two are 4, so the next one would occur at 7 pi over 2. Okay, so minimum values are going to occur at values of 2n pi minus pi over 2. Okey-doke. Not so important to memorize, but nice to know. So let's find the sine of negative 5 pi over 2. Well, we know that the sine is a periodic function. So our graph doesn't go to negative pi over 2. But if I were to find a coterminal angle that's on our graph, then we could find the sine of negative 5 pi over 2. So remember, to find a coterminal angle, we either have to add or subtract 360 degrees or 2 pi in this case. So what I have is negative 5 pi over 2 plus 2 pi. 2 pi, as you know, is 4 pi over 2. So I have negative 5 pi over 2 is 4 pi over 2, which is going to give us negative pi over 2. If I go to the graph at negative pi over 2, it would be right here. I can see that the value of the graph, or the y value, is going to be negative 1. So the sine of negative 5 pi over 2 is negative 1. Okey-doke. Okay, here's one for you guys to do. I'm going to be doing it up here as you do it on your own, so best of luck. Okay, what I did was subtract multiples of 2 pi, and I could have started with a bigger number. So I subtracted 4 pi because I'm making a coterminal angle. And it wasn't quite big enough, so I subtracted 4 pi again, and I ended up with sine of pi over 2, 90 degrees. Sine of 90 degrees is 1. So there you have it. Okay, let's look at the cosine function. What is the domain of the cosine function? Well, every value of x is on the graph, so we are going to say that the domain of the cosine function is all real numbers. Very ugly. What is the range? Same as the sine function. Starting at -1 and including -1 up to 1, including 1. What is the y-intercept of the cosine function? The cosine function starts at the point 0, 1. What about the x-intercepts? Well, where does it cross the graph? Let's go through the same process we did with the sine function. Crosses here, -3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2. Probably crosses again over here at 5 pi over 2. So what we're going to say is that the x-intercepts are odd n pi over 2. Ugly, but whatever. The max values again go up to 1, but where do they occur? Well, let's look. I have a max value here at -2 pi, one here at 0, another one here at 2 pi. So we're going to say the max values occur at even pi's, even n pi. So at 0, 2 pi, 4 pi, 6 pi, and so on. Where do the minimum values occur? At -pi, at pi, the next one would be 3 pi, so we are going to say they occur at odd n pi. Okey-doke. So you, of course, can graph sine, cosine on your calculator. It's really much easier. When we do that, we have to change our calculators into the trig window. Let me show you how to do that. Okay, so I have sine of x entered into the graph function of my calculator, and if I were to graph that, look, I get a straight line, not very pretty, but that's because of the window. So what I need to do is go to Shift, View Window, and right here under F2 you're going to see a trig window. Right now, as you know, the standard window is -10 to 10. If we select the trig window, it's going to go from -540 degrees to 540 degrees with a scale of 90 degrees. Your y-min will go from -1.6 to 1.6. And you might have to change that depending on whether you stretched your graph or not, but this is a good starting point. So if you're graphing trig functions, always select the trig window. So here, let's try drawing it now. Beautiful. So, yeah, there you have it. So here's the picture from your calculator, and what you need to remember here is that every vertical mark is 1/2, or 0.5. And every horizontal mark is 90 degrees, or pi over 2. We can use the trace function on your calculator to evaluate trig functions. In this example, we see that the sine of -150 equals what? It equals 0.5, or -0.5 actually. So to do that on your calculator, I'll show you how to do that real quick. We've used the trace function before, but make sure you always enter your value, otherwise it might not stop exactly on the point that you want it to, and you'll lose accuracy. So here's your trace function. Just hit Shift, Trace, and now I'm going to enter what I want. I'm going to enter -150 degrees. Execute. There we go. Y equals 0.5. And I can enter another one like if I wanted to now, like let's say I want to do 135 degrees. Oops, that's not right. Execute. It's 0.707, which is really √2/2. So there you have it. Okay, at the beginning here, I mentioned that word sinusoid several times. A sinusoid is just a function that can be written in this form. it can be written as a sine function. So we can write it as y equals a sine bx plus c in parentheses plus d. And you'll probably recognize these as the changes that we've been doing to all our graphs: up, down, left, right, vertical stretch, vertical shrink, horizontal stretch, horizontal shrink. However, because this is a periodic function, they're slightly different. Cosine of x is a sinusoid because, as you can see from the graph, it's just the sine graph shifted 90 degrees left. Okie doke. So what I'm going to have you do now is a graphing activity. So you should be getting a sine and cosine graphing worksheet. You're going to graph each sine function, cosine function on your calculator. Make sure you use the trig window. Draw the graph on the worksheet. Find the characteristics listed, such as domain and range and whatnot. When you're finished, we'll go on. So have fun. Okay, let's review what you learned with that worksheet. The amplitude is what we call the vertical stretch of a sinusoid. So amplitude. Amplitude in our function here is a. Graphically, the amplitude is 1/2 the total height of the wave, and that's from all the way in the top to all the way to the bottom. So for a regular sine graph going from -1 to 1, your amplitude is going to be 1 because it's 1/2 of 2. So looking at this equation here, let's find the amplitude of the function. And actually, since amplitude isn't positive or negative, it's really the absolute value of a. So if you have a negative number, you're just going to make it positive. Here, the amplitude is -2. We would take the absolute value of -2, which is going to be 2. Period, we can find as well from our equation here. To find the period of a sinusoid, what you're going to do is say that the period, P, is equal, normally the period is 2. But what we're going to do is divide that 2 by our B value, which is right here. So let's look at this function and try to find the period. Well, our B value is 3. So what I'm going to do over here, set the period equal to 2 pi. We're going to divide it by our B value over 3. So I have one complete cycle of the sine function in 2 pi over 3. Okay? Which is 120 degrees. So we also can have a horizontal shift of the sine function. Phase shift, if B is within parentheses here, is given by -c over B. Now, if we take the B out of parentheses and like this, and have it now multiplying the quantity x plus c, the phase shift is going to be -c. So when you find a phase shift, you have to check to see if B is inside or outside of the parentheses. Okay, so we can shift our function left or right using a phase shift. So let's look at this first equation here, and I can see that B, value of 2, is outside of the parentheses. So when we're outside of the parentheses, the phase shift, PS, is going to equal -c. So I'm going to go over here and find my c value, which is -pi. So that's going to be the negative of -pi, which is going to equal pi. So my phase shift is pi units to the right. Now in this next equation, I see that my 2, or my B value, is inside the parentheses. So that means the phase shift is going to be -c over B, which is going to be -pi over 2. function has shifted negative pi over 2 or pi over 2 left. Remember how we said inside and outside the function? Because this is a positive, it's shifting left, pi over 2. So to summarize, the phase shift, b is inside the function, hopefully your writing is way neater than mine, the phase shift is going to be negative c over b. And then, if b is outside the function, or outside the parentheses actually, the phase shift is going to equal negative c. Okay, so inside or outside the parentheses, that's how you find the phase shift. Okay, when talking about sinusoids, you also might hear the term frequency used before. Frequency is something that we hear, for example, with sound waves, which are sinusoids. They're how often they occur. So the frequency of a periodic function is just the multiplicative inverse of the period. So what we're going to do is say the frequency f equals 1 over p. Okay? Graphically, the frequency is the number of complete the cycles the wave will complete in one interval. So normally your frequency would be 1 over 2 pi. So in one interval of 2 pi you'd have one complete cycle of the sine wave. So let's look at this function down here and let's find the period, amplitude, and frequency of the function. Well, we can see that our a value right here is 3. So a, the absolute value of a, is going to equal 3. That's our amplitude. Here, I can see that my b value is 1/2. So my period is going to be 2 pi divided by 1/2, which is 4 pi. Last of all, I need to find the frequency. Frequency is 1 over p, which is 1 over 4 pi. So there's one complete cycle in 4 pi. Okay, back to our sinusoid equation. Just like in all our other functions, the vertical translation occurs outside the function. So here we're going to go up and or down d units because that's where we're adding. So right here, the vertical translation of our function is d. So let's look at a function down here. What's the vertical translation? Well, it's the number outside the function that we're adding or subtracting. We're going to move down 4 here, just like every other function. So let's write a function now. Let's write the standard form of a sinusoidal function whose amplitude is 3, its period is pi, and it passes through the point 0, 0. Okay, what we're going to do is start with our basic sinusoid function and replace the appropriate letters. So let's look up and see what we're asking here. It's saying our amplitude is 3. Well, that's simple. That's just going to be our a value. So I have f of x equals 3 sine. What else do we know? The period is pi. So let's find out what our b value is. So p is 2 pi over b. So if our period is pi, pi equals 2 pi over b. Divide pi out of each side, multiply each side by b. That was a b, by the way. And I'm going to get b equals 2. So now I have 3 sine of 2x. It passes through 0, 0. Well, I know that a basic sine function starts at 0 and it goes up to 1. So that tells me there's no shift at all. So that means there will not be a c value, and nothing is mentioned about moving up or down, so there's no d value. So this is my function. F of x equals 3 sine of 2x. Okay? Okay, now that we know how to write an equation of a sinusoid, let's try writing an equation and graphing it. So we're going to construct a sinusoid with an amplitude of 1.5 and a period of pi that goes through the point pi over 2, 0. Okay, well, we know our amplitude is 1.5. So let's write our equation. Y equals a sine bx plus c in parentheses plus d. So far I have y equals 1.5 sine. Now, we know as well that our period is pi. So let's find out what b is. So p equals 2 pi over b, which implies that pi is 2 pi over b. Cancel out our pi's, and we get b equals 2. So I have sine of 2x. Now let's find out what our phase shift is. Well, normally the sine curve starts here at 0, 0, but now it's starting over here at pi over 2 and going up. So we can say that our phase shift is going to be right pi over 2. And because we're just using c instead of c over b, we're going to put our parentheses here. Get rid of that one. It doesn't mention anything about going up or down, so I think we're done. Our equation is 1.5 sine of 2 times the quantity x minus pi over 2. Okay, let's draw it. Well, what I'm going to do is start here at pi over 2. So that's pi, 3 pi over 2. So pi over 2, pi, 3 pi over 2. And right here we'd have 2 pi. I know that I have one complete cycle from pi over 2 to 3 pi over 2 because that's 1 pi. So what I'm going to do is draw, I'm going to hit the halfway point. My curve right here. So I'm going to go like this, down to negative 1.5 and back up to 3 pi over 2. Okay? So every pi over 2 I have a complete cycle, or one complete half of a curve. So it should look something like that. It's very ugly, I know, but it's the best I can do with this. Okay? So now that we know what it looks there, let's just come over here and do it. At pi over 2, I'm going to start. I have one complete cycle for pi. And then I just have to repeat. This way. Anyways, that's how you draw a graph. So there you have your sine graph. Okay, last problem. A certain person's blood pressure oscillates between 140 and 80 if the heart beats once every second. Okay? So let's try to write an equation for this. So first thing I'm going to do is try to draw the graph. It's going to start here, look something like this, right? Because I know it's oscillating between 80 and 140. So that's a difference here of 60, which means it's going up 30 from the middle point and down 30 from the middle point. So halfway between 80 and 140 is 110. Okay? So I know that D is going to equal 110. So the other thing I know that the heart beats once every second. So that means the distance from here to here is going to be 1 second. This would be 1 second as well. So I have one complete cycle in 1 second. So my period is 1. I have 1 equals 2 pi over b, which means that b equals 2 pi. So my equation is going to be y equals my amplitude, up 30, down 30. 30 sine b is 2 pi x. Now, there's no mention of a phase shift here, no mention of an up or down, so we are done. Well, that kind of wraps it up for the day. You guys can do the language objective. Don't forget to do your homework. And if you have any questions, I will be here on Monday. So come in and see me. Have a great one, guys. See you later.